Good morning, everyone. I am D. Sengotayan, Assistant Professor of Physics, SNS College of Technology, Coimbatore. Today, we are going to study about crystal space lattice. So, the first of all, the title is Crystal Physics. So, we are going to studying about crystalline nature. So, basically, the difference between crystalline and non-crystalline. Crystalline materials are having regular and periodic arrangement of atoms or molecules in 3 dimensions. Then irregular or random arrangement of atoms or molecules are called amorphous materials or non-crystalline materials. So that the first point is lattice, then space lattice. So lattice, it is denoted as position of atoms or molecules in 3 dimensions. Then the space lattice, the points in the space, it is called space lattice. Then the next important topic is basis, that is unit assembly of atoms or molecules which are identified with respect to the position of lattice point. That means repetition of basis correct periodicity is in all directions. Then the examples for basis: aluminum, barium, NaCl, KCl. Then the value of number of atoms in basis 1, 1, 2, 2. So the next, the diagram shows that the crystal structure, the first point shows that the lattice point, then lattice plus basis is equal to crystal. So we already known about lattice point, that is position of atoms or molecules. Then the basis is equal to unit assembly of atoms or molecules. Then the lattice point joined together with the atoms are called crystal structure. The next, unit cell, the fundamental building block, repetition of atoms or molecules in various directions. Okay, next the lattice parameters. So lattice, it is known as lattice point, lattice line or lattice plan. If you point one particular level, that is called a lattice point, that particular space equal to lattice point. Then in 3 dimensions, the axis x-axis length equal to a, then y-axis length equal to b, then z-axis length equal to c, that is called axial length of x, y, z. Then if the condition is a equal to b equal to c, all are equal, that is called cubic structure. Then the angle alpha, beta, gamma, alpha equal to the angle between a and b, then beta the angle between b and c, then the gamma is the angle between c and a. Then the next title is primitive cell. A unit cell consists of only one full atom, that is lattice points at corner only, that is called primitive cell or simple. If the lattice point consists of more than one lattice point, that is called a non-primitive cell. The first diagram shows it a primitive cell, that is example for primitive or simple. The diagram's name is simple cubic. Then second, BCC, bodies in the cubic, then face or base in the cubic are called non-primitive cell. So that the example for primitive cell, it is simple cubic. Then example for non-primitive cell, bodies in the cubic or face in the cubic. Okay, the next to the crystal structure, the main point of crystal, the crystalline nature, that is lattice, unit cell, then primitive, non-primitive cell. Then finally the different types of crystal system. So the diagram line shows that the different systems. The first one is cubic. The axial length a, b, c, that is a equal to b equal to c, alpha, beta, gamma all are equal to 90 degrees. It is called cubic structure. The next one is tetragonal. In tetragonal, the axial length of x-axis a and y-axis b are equal, then not equal to c, as well as alpha, beta, gamma are equal to 90 degrees. That is called tetragonal. Then orthorhombic, a not equal to b not equal to c. Then the interaxial angle alpha equal to beta equal to gamma equal to 90 degree. Then the next system, rhombohedral, axial length all are equal, interaxial angle also all are equal but not equal to 90 degree, that is called rhombohedral structure. Then hexagonal, axial length of x and y, a equal to b but not equal to c, that height is not equal to length and breadth. Then the angle alpha beta equal to 90 degree but gamma equal to 120 degree. Then the next structure, monoclinic, all are axial length all are not equal, and also alpha and gamma equal to 90 degree but not equal to beta. Then finally triclining, the system shows that all are not equal, A not equal to B not equal to C, and also alpha not equal to beta not equal to gamma not equal to 90 degree. So these all are the 7 systems are available in the crystalline nature.